All right, so thank you for coming to my presentation, Warusagi, a malicious USB. So as Jaden said, my name is Tai Van Dam. I use she, her pronouns, and I am a senior analyst at one of the team leads at the CSSCD, and this is my second time presenting at the Conspiracy. Presented to everyone so far, so that's nice. This time I wanted to explain my process of going from an idea to a functional tool for a malicious USB attack that can give remote access to a device within 1 minute of physical access to that device. So for my birthday several years ago, I got a Raspberry Pi Zero, which if you don't know, it's a tiny single board computer about the size of a credit card. And over the years, I've had many ideas of things to make with it, but I never ended up committing to anything, and so it just sat in a drawer or a desk for, what, probably now 5 years. But then this year, when I was trying to come up with an idea to present to this conference, I remembered the saying, hackers make their own tools. And I remembered that Raspberry Pi Zero, and I was like, I'm going to do something with that. So I decided that I wanted to make some kind of a pen testing tool with my Raspberry Pi Zero, and present the process of making it to you and show you the steps along the way. And show you it in action if I have time, hopefully. Now, in order to make this hacking tool, I went through 5 different steps. The idea, the planning, the building, the testing, and until I had a functional tool. So, the first stage of my project was planning. Obviously, I already had an idea of what I wanted to do, but I had no idea of exactly what I wanted it to do. So after doing some research of things that I thought I might be able to do, I came up with a list of things that I saw other people do online, such as having the thing be a malicious USB attack, a general purpose Wi-Fi hacker, and an RFID cloning tool. That's when I realized I am a full-time student with a job, so I decided to cut that dream into something a little bit more manageable and make it only work as a malicious USB. Now, I had seen someone do a project like this before with a Raspberry Pi Zero, so I figured I would follow their steps and build on that to make my own attacks. Now that I had an idea of what I wanted to do, let me explain to you what exactly a malicious USB is. So, as with any attack with a pen testing tool, a malicious USB takes advantage of an aspect of computers that the designers either did not anticipate or didn't anticipate to be a problem. And that is that any human input device, or HID, like a keyboard or mouse, is always explicitly trusted by the computer. So, in that way, the malicious USB is able to pretend to be a keyboard and mouse and put pre-programmed commands through to the computer by typing them out. Now, the most popular example of a malicious USB is the Bad Bunny. It's a tool sold by Hack5, which is a company, and it can be programmed using a simple language called BunnyScript. This project I built my malicious USB on, however, is called the PonPi Aloha, which is an acronym for a little offensive appliance. The actual building of the PonPi was incredibly easy. The only things necessary, aside from the Raspberry Pi itself, were an SD card, which acts as the entire storage of the device, and the USB add-on board to make it look a little bit more like a thumb drive. Obviously, you could probably print a case and make it look even more, but I never did get around to doing that. Attaching the board only needed a couple of plastic screws, and it was done in like 5 minutes. So once I followed the steps in the first instruction manual I found to boot up the device, navigate to the Wi-Fi point created, and go to the IPv4 address of the web portal, and I thought I was ready to start pawning computers. And that's when I realized I really have no idea what I'm doing here. Because I was presented with all these drop-down menus and settings that I really just didn't know what they did. So my first step was to start looking online for other people who had made this project. I found lots of different guides that were varying degrees of help. I found that most of the guides brought me right up to the point that I was already at. Here's how to get the image, here's how to boot into it, here's how to connect to it, here's how to run the test scripts, now go have fun. And I was a little bit lost. And then I also found some guides that were obviously made for people who had already understood how this worked and were doing extra add-ons and stuff. Honestly, the only thing of value that I gained from this research was coming up with the name for my device. I had found a guide, one of the more complicated ones, about how to add a switch to control the payloads, from a man in Australia named William McLean. And he decided to name his device the Bilby, because a Bilby is a kind of thing that's almost like a bunny from Australia. And so I decided I wanted to name mine Warusagi, which is a literal Japanese translation of bad bunny, because I grew up in Japan and I figured I might as well bring some of my culture into it. Now, my only way out of this hole of not knowing what to do was what I had been dreading. Obviously, when I downloaded the image off of GitHub, it came with a README file. And this instruction manual was over 4,000 words. And to be honest, it kind of scared me going into it. So I buckled up and got ready to go, and it ended up being way easier than I thought. The README was structured to take you step by step through each functionality of the tool and built on each of the previous steps with new practical information. So now, armed with these new tools, I was able to work through and understand how to set up payloads and make them deployable. Now, the first script that I wanted to develop was one that would automatically open up a web browser and navigate to a link and press the spacebar. The scripting language used for this device is pretty self-explanatory. There are a couple of commands I want to bring your attention to. The first three basic commands are type, press, and delay. The type command will input just whatever you type in the string here, including enters by putting the end of line key, which is \n. The press command will press key combinations. So if you wanted to do, say, Control-Alt-Delete, then it'll send those commands all at the same time. And the delay command waits the number of milliseconds that you specify before performing the next command. So the final command I want to bring your attention to is the wait LED command. This one is not very self-explanatory, but it is very important. What this does is it waits until it gets a signal from the keyboard, because all keyboards on a computer share the status of the caps lock, number lock, and what's the other one? The other lock key. And so what this does is it will wait until it gets that signal from there, so that you know that all of your keyboard drivers are set up and the device is all booted up. So this is a pretty simple script, but I wanted to make sure that I could get things right. So now, this attack would be done by, dropping a USB somewhere and then having someone plug it into their computer. So I want to call up a volunteer to plug it into my computer, and we'll see what it does. Does anyone want to do it?
Plug that in your computer?
Yeah.
Okay.
Go for it. So here, right here. Just into one of these. Mine doesn't have actual USBs.
This way?
I think it's upside down.
So you see my level of knowledge.
Well, it's a USB. Everyone does that.
Connected.
Yep, it's connected. Now, it'll take a minute to boot up, but I will tell you when it's about to start happening.
What's the press GUI control?
Oh, the GUI, that stands for the Windows key, or whatever the multifunction key is. That's the key code for that in this script.
So, is this OS agnostic? Like if we run Mac, would it hit command?
Yeah, it would, yeah.
Awesome. Okay.
Oh, and it's going. So, and that's how you can use this. What else would it be? Now, my next step was to try to do something a little bit more malicious. I decided that I wanted to make a payload that would open up some kind of a backdoor in a target computer in only a small amount of time. I decided that the best way to do this would be to save the password and hashes and open up an SSH server. This way the password hashes could be cracked later on, and the computer could be accessed via the SSH server. Now, I started off trying to do this on a Linux machine and found I was not going to be getting much anywhere without any kind of sudo access, so I decided to switch over to Windows. First, to develop this, I walked through the process myself and listed out all the steps that I did, every key press, so that I could then program it into the device. I also decided to use an obfuscation method with Windows PowerShell called encoded PowerShell. That's what these are. here. So what encoded PowerShell is it's designed to for doing PowerShell commands with characters that PowerShell does not normally accept. And essentially, you can encode the command with in base 64 and run it by typing PowerShell.exe-e for encode, and then the command there. So what this is, for instance, is literally just this command here. So for this attack, I have it executes 3 different commands. One of them copies the username of the user and the IP address information onto the USB. The next one copies the 2 files that are needed for cracking the password. And the final one opens up the SSH service and sets it to starting automatically. This one uses the wait LED repeat command, which is a little bit different. It just waits until you change the LED status 5 times quickly. And this one is specifically for the number key because for this attack, I couldn't do the regular wait LED command because once the keyboard is set up, it doesn't necessarily mean that the removable storage is also set up. And so I was running into some issues with doing that all automatically, so I figured that this one could just be manually triggered. So now I'm going to need just a second to switch over the scripts, but I'm going to demonstrate this one as well. Now, for this attack, because I'm doing it on a Windows computer, I'm going to be using a virtual machine. So I'm going to need to essentially pass the... And I need a second computer to actually SSH into the first one. Oops. That's not going to work. Okay. So this is going to be our target machine. So I'm going to plug the USB in, and it's going to first be on the Linux computer that's underneath, and then I'm going to have to pass it through into the VM once it's set up. Okay, now with that popping up, I know that it is set up, and now I can do, this is essentially just plugging it into the Windows computer. So now it's been plugged into the Windows computer, and it'll take another second here. Actually, I'll know when, there we go. And now, all I have to do is press number lock 5 times. And it will start. I think there might be a little bit of an issue. It wasn't able to open up the administrator. So it's not going to work this time, but usually it does. I can just open up the SSH server myself real quick.
This on a regular machine that didn't have local admin rights on it, would your script still work?
Well, it would be able to exfiltrate the hashes and stuff, but it wouldn't be able to start the SSH session. That was the only issue that I had with the administrator. Dang, this thing's moving slow. Probably because I got 3 computers running on this thing now. Perfect. Oh, perfect. It did end up opening up the SSH server. So now I can go over to my attacking computer. Now these 2 computers are both on the same local network, so that is something that needs to be done. Now I can look on here. I could just unplug this USB, but I'm just going to use this because I don't feel like actually doing that. But on this drive, I have the username of the user, the IP address information, and these 2 files can be used to crack the hashes, but I'm not going to do that right now because I don't feel like waiting for that. I just set the password to this computer as password, so we're just going to do that. So if I go over here and copy this IP address, and then I can just type password, and I'm now in the Windows computer. So now if you'll look, there's nothing visible on here, but I am currently running on this computer. So if you see, I've got this secret file on the desktop, so I can say and you can see that I'm able to see that secret file.
That the local user is an administrator or an admin?
It does have to have like, it just needs to be able to open up the administrator PowerShell. So basically, yeah. Yeah, so that is how the malicious USB attack works. I hope you enjoyed my explanation of my process of creating it. And I think I have time, yeah, I've got time for some questions now. And if you've got any further questions, I'll be hanging around this room pretty much all day. Yeah.
Do you have a how-to guide that is possibly shareable? No, frankly, I would like to test this in my own environment.
Yeah.
Now I'm kind of freaked out.
Yeah, I can.
Big full disclosure.
Yeah, I can send you the if you want to just like give me your email address or whatever, I can send you the link to the GitHub repository. And like I said, I pretty much just followed through the README and was able to do this stuff myself. I can also send you the payloads I used if you want.
Yeah.
Yeah.
I appreciate it.
Yeah. Yeah.
So it looks like when it failed, it might have struggled because of the delay command, just because it was.
Yeah, I would probably just set it to higher delay.
Are there ways around that? Can you find some way to like recognize the screen as to whether it's execute the command?
See, the issue is that basically all it is a keyboard and mouse, and so usually the computer does not give any of that information to it. So really the only sort of like, I'm not sure how you would do like detection of like what's happening on the computer. I would have to look into it more, but I know that there have been people who've developed pretty complicated payloads for this for the PalmPy system. Like there's one that was basically you could just plug it into any like logged off Windows computer, and I'm not sure if it works anymore because it was a little bit ago, but you could plug it into a logged off computer, and if they've got a weak password, then it'll automatically like find the hash and crack it there and type it in and log you on immediately.
So you
Yeah.
think that, well, I am a little bit hesitant to give you my email and password because, well,
Yeah.
do you think this vulnerability has already been addressed by either Microsoft or Apple or something?
Well,
This is an entry, an open entry.
Yeah.
It's open. I mean, this is just out.
yeah, so really, because it is, because like I said, keyboards and mice are explicitly trusted, because you wouldn't want to have a computer with no keyboard and you plug in the keyboard and it doesn't work. There's not really any way around that. The only way around it is to just disable USB devices on your computer, which most computers are able to do. But then, you wouldn't be able to use your own keyboard and mouse unless it's like a laptop or something with built-in.
Yeah.
Thank you.
Yeah.
So where do you take this next? Like in your
Honestly,
ideation, how do you improve on what
I probably would go through and like, I think probably the next thing I would want to try to figure out how to develop would be something like that that password cracker that I was talking about, the one that, I mean, it basically, and it goes through John the Ripper. But I would probably try to develop something like that that could crack the password. I think also one big issue with this attack is that on the Windows computer also needs to have the SSH server already like set up. It just needs to be enabled with the device. So I could possibly make it to where it would also like basically install the SSH service, like enable it. But I wasn't able to get like the timings on the delays and stuff right to be able to do that. So I would probably try to do something to make that work. Yeah?
I had a question about how quickly it sees it as a keyboard and mouse, because
Yeah.
like for the regedit, a lot of times you're disabling like the storage or the readable media, but people
Yeah.
are still able to like plug in a literal mouse and keyboard USB.
Yeah.
So like would that regedit block this malicious USB?
I am not 100% sure on that. I'd have to check that because I mean, as far as I can, so this attack, because it also mimics like a removable media, it probably wouldn't. This one wouldn't work. But doing anything that's just keyboard and mouse, I would assume that if keyboard and mouse are enabled, it would work. But that would be something interesting to test.
Thank you.
I can do maybe one more question. Yeah.
Have you, after kind of going through and seeing your exploit run, gone back through the logs or sysmon or whatever may be kind of deployed on your base Windows image and looked at what a blue team detection side would see?
Well, this one, I mean, it's pretty messy because it's a very like basic attack. But you could probably just go through to the PowerShell logs, and you would see that the encoded commands were run, and it might be hard to just like straight up recognize what it's doing, but you can always decode it and see what they actually did. All right, now I think I probably need to pack this stuff up so that the next presenter can get ready. So thank you. I will, like I said, I'll be around this room pretty much all day. So if you got any more questions, feel free to ask.